It may not surprise you to know that I was somewhat dragooned into this. It's kind of like, suddenly I get an email from Joe, hey, have you got the programming contest done yet? And I was going, no. And he says, well, you know, if you can't get one, that's okay. We'll live with the crushing disappointment and sense of personal betrayal. But if you do get one going, that would be kind of cool. And as you've heard me say, despite doing this for money for 30 years, I've got a degree in biology and I have very little formal computer science education. I'm not an algorithmist or mathematician. So I used a very simple problem that I came up with in college to benchmark my TI-52 calculator to find all three-digit numbers equal to the sums of the cubes of their digits. And the first solution I came up with was just a loop that started with 100, went up to 999, took each number and by modulo and integer arithmetic, peeled it apart, cubed each digit, added them, so on. It works, but it's kind of slow, and through the intervening decades, I optimized it. And so I had I thought I had a moderately good idea after looking at this problem for so long about some of the reasonable optimizations that could be applied. But you'll remember my little caveat a while back about being neither an algorithmist nor a mathematician. So, probably not a surprise to let you know that there were no bad entries. All of the entries were quite good. If I ranked them from best to worst, the worst entry is still slightly better than anything I've come up with. So there's that, humbling. The solution I run in my DM42 pre-computes the cubes of the digits 0 through 9, stores them in the register 0 through 9, and then I have 3 nested loops for tens, hundreds, and ones, and I walk those loops and I use indirect addressing to peel the cubes out and add them. I thought that was about as good as it could get. Oh, my worldview was so simple and jejune. Anyhow, I should have put a few more constraints in this contest. I didn't say if I was looking for speed or space. I made the foolish comment that you could program this in anything you wanted, and so people did. So I've split the awards into 4 categories. Got classic RPN, you know, HV15, HV67, 97. Got modern RPN, which would be 41, 42. Got RPL. And Namir even did it on the prime, but honestly, doing it in the prime is so trivial, I just laughed gaily and threw that one away. But there are going to be 4 awards. There's going to be a classic RPN.
We only have 1 award.
No,
You have 4 certificates, but there is an overall award.
Richard, there's 4.
Okay.
There are 4 awards. We're going to have an award for the best classic RPN, the best modern RPN, the best RPL, and then an overall award. So on my thing I said impress me, and honestly, everybody impressed me. Let's start with the classic RPN entries. Had 3 entries there. Chuck McCord, he had the smallest RPN program and he ran it in an HP 15. And so if I were judging by small, he would win. But I somewhat arbitrarily decided that since it took forever to run, I wasn't going to judge for small. Still, good effort, Chuck. Namir Shammas and Olivier, is that pronounced that? Arbey? Olivier? Okay. They both came up with interesting, similar mathematical solutions. And for example, you know that if a 3-digit number has 2 9s in it, it can't possibly be considered. And once you see that it has 2 9s, you can stop considering it because 9 cubed is what, 729? So that's just not going to work. And both Namir and Olivier came up with shockingly similar observations and optimizations, although I would certainly never accuse them of collusion. However, Namir's solution is 4 steps shorter. Namir wins the classic RPN. Good for you, Namir.
Namir Shammas.
Yep.
We have RPL, PPL, RPN, and blank.
Give him, well,
We could make this from the classic RPN.
make that the classic.
All right.
We're gonna have to change two of them, because one of them,
One of them was PPL.
PPL, just scratch that out for Big Ugly X and put classic RPN in there.
After all, it's the same guy.
Yeah.
I mean, I can have a double like a, you know.
Don't
push it.
Don't push it.
That was done after midnight last night.
Now,
I kid you not.
when you get into the general drawing, you should have spent the last day and a half
After that dries, you can put a window on.
salivating over what you want. Now, it may not be there when you get up there, but most of you will be taking 3 trips to the prize table. Try to have a first, second, third, and fourth so you can get it and get out of the way. Otherwise, they'll be here all night.
We had 3 entries on the DM42. I'd expected we have more, because for RPN, that is just, basically that's it. There can never physically be a better RPN calculator. You can't do anything, that's it.
So RPM.
Eddie Shore submitted the smallest entry at a mere 80 bytes. But it was also, again, the slowest, because it was the peel a number apart cubes, so it went through the cubes every time, but still, it was tiny. Craig Bladow, is that how you pronounce that? Bladow. Craig Bladow, you'd think I'd know after all these years, but I actually never hear anybody say your name. Craig Bladow and Dave Hayden both came up with really fascinating optimizations based on excluding large swaths of the 100 to 999 by various checks. For example, Craig noted that numbers with more than 1 9 in them, or a 9 and an 8, or a 2 8 can all be excluded. Dave computed partial sums of cubes, and if you've added 2 of the 3 cubes and you're already bigger than the number you're checking, you can just stop at that point. So both of them, it's a little tricky because I have to sit there and try to stopwatch time it. But Dave's solution is, to the best of what I can do manually, I would guess it's about 2/10 of the solution faster. So Craig, you were very good, but Dave was faster, so Dave wins. Dave wins all.
Hayden.
How many program steps was it, Dave?
66, including the end, I think, yeah.
Congratulations. And you'll have to get David to sign.
Okay. I'll sign them all.
I kicked the prize.
No.
Later?
Just the main winner.
Just the main winner.
All right.
We had 3 entries.
Main winner? All right.
We had 3 entries for RPL. Now, I just don't do RPL. I mean, I did 4th in the Apple II, and I decided that languages like that were just bad, evil. So I got Joe, and I gave Joe the entries. We had entries from Roger Hill, Bill Butler, and Joey Shepard. Now, Joe looked at them, and he gave me little notes on each of them. And the notes were all along the line of very clever optimizations here. You know, look at the way he's using list processing here. So all the RPL entries were apparently quite good. But at the end of the day, Joey's solution took 37 seconds to run. Bill's solution took 7.6 seconds to run. And Roger's solution ran in 4.8 seconds. So, Roger Hill, an inspiration to me personally, wins the RPL part of the contest.
Making a window for it. Thank you.
Last,
It's for the fun.
one of the fun parts about these contests
Toss that out.
is you see people sometimes going the extra mile. And if I were, when I've done programming contests in the past, and by the way, I have never won, I don't think I've ever even been mentioned, but I'm not bitter about it. So most of us will pick one calculator architecture that we really like and we'll run with it. One of the entrants submitted classic RPN, modern RPN, and prime.
Wow.
And all solutions were good. So for extra effort, the main award goes to Namir. Now, Here you have two choices. This is my donation. This is a full Raspberry Pi 4 4-gigabyte kit with power supply, little case, and a fan, and everything you need except, as I found out, the micro SD card. You may have this, or anything over there. Anything over there.
You wouldn't get anything. I mean,
Anything off the prize table, or
Not the prime.
Not the prime.
not the prime. No,
Okay.
this is really much nicer than anything over there. But I would say I wouldn't really consider it a personal insult if you didn't choose it.
I hope not.
I'll put it on the table.
Put it on the table.
Not that.
4 gigabytes, folks, on the Raspberry Pi, quad-core processor, 2-point-something gigahertz. It's a great grandma computer. It occurs to me that none of us have living grandmothers. Okay, well, maybe, what's his name, the kid. All right, that's all.
Thanks, Bill.